Hey there, curious minds! Welcome to another episode of I Wonder, the show where we explore the questions you've been wondering about. Today's question comes from Zoe, who lives on the coast of San Diego, California. Zoe wrote that she was watching her goldfish sprinkle and noticed how its mouth is constantly opening and closing, like it's trying to say something. Zoe asked, "What exactly is happening in there? And how do gills actually let fish breathe underwater when we can't?" Let's dive in.
Wow.
To solve Zoe's mystery, we first have to understand what breathing actually is. Whether you're a human, a dog, a spider, a goldfish, or even a pink fairy armadillo, yep, that's a real animal. Your body needs oxygen to turn the food you eat into energy. It's like the fuel that keeps your internal engine running. We get our oxygen from the air, but fish get theirs from the water. Now, if you look at a glass of water, it doesn't look like there's air in it, right? But there is. It's called dissolved oxygen. Tiny molecules of oxygen gas are actually trapped between the water molecules. The challenge for a fish is that there isn't very much of it. In fact, air has about 20 times more oxygen than the same amount of water. This means fish have to be absolute experts at mining oxygen out of the water. This is where the gills come in. If you've ever looked closely at a fish, there are flaps on the sides of its head called the operculum. These act like protective doors for the gills. When Zoe's goldfish opens its mouth, it's not just being chatty, it's actually pumping water. The fish takes a big gulp, then closes its mouth and squeezes its throat and forces the water backward and over the gills. Most fish have several gill bones called arches on each side of their head. Attached to these arches are thousands of tiny feathery threads called filaments. These filaments are the real stars of the show. If you looked at them under a microscope, you'd see they are covered in even smaller flap-like structures called lamellae. This design is a masterpiece of efficiency because it creates a massive amount of contact space, which is just a way of saying that the oxygen has more places to enter the fish's bloodstream. By having thousands of tiny flaps instead of just a flat, smooth wall, the fish can process as much water as possible to extract oxygen. If you could unfold all the gills of a large fish and lay them out flat, they might cover the entire surface of a small rug. The more of this surface area the gills have, the more oxygen they can grab. Inside these tiny flaps are even tinier blood vessels called capillaries. These vessels have walls so thin that oxygen molecules can just wiggle right through them and into the fish's blood. This process is called diffusion. It's a bit like a crowded room. Nature likes to move things from where there's a lot of them, like the oxygen-rich water, to where there's less of them, like the oxygen-poor blood. As the oxygen moves in, a waste gas called carbon dioxide moves out of the blood and into the water. This gas exchange is exactly what happens in your lungs, just with water instead of air. Here's a fun fact. Fish have a trick about breathing that makes them even better at it than we are.
What?
It's called a counter-current exchange system. A fish's blood flows in the opposite direction of the water moving over the gills. This gives the blood a much better chance of absorbing oxygen. If a fish's blood moved in the same direction as the water, it would feel like breathing on top of a giant mountain. You could still breathe, but the air would feel thin and you'd always be gasping. By flowing in the opposite direction, fish can soak up almost all the oxygen available. So, why can't fish breathe on land? After all, there's way more oxygen in the air than in the water. The problem is the structure of the gills. Remember those feathery filaments? In the water, they float freely, like your hair when you're in a swimming pool. This keeps all that contact space open. But as soon as a fish is taken out of the water, these filaments lose their support. They all stick together and collapse into one big soggy clump. Once they clump together, the inner parts of the gills aren't touching the air anymore, so the fish can't get enough oxygen to survive. There are also some pretty wild exceptions to the rules. Some fish, like the mud skipper, can actually spend a lot of time on the land. They have special gill chambers that they can fill with water before they come out, basically carrying an oxygen tank with them. Others, like the lungfish, actually have a primitive lung and can breathe air directly. But for most fish, their gills are finely tuned instruments that only work when they are submerged and wet. Another interesting exception on how gills work would be sharks. It's a myth that all sharks have to keep swimming to survive. Only sharks like great whites and macos. While many fish can use their cheek muscles to pump water over their gills while they're sitting still, which is called buccal pumping, these sharks actually lack those muscles. Instead, they rely on ram ventilation. This basically means that they have to keep their mouths open and swim forward to ram the water over their gills. If they stop moving, the water stops flowing, and they stop breathing. While this might sound bad, it has its benefits. Ram ventilation is more efficient than buccal pumping. These sharks are always ready to hunt and move faster than other sharks. It's a great example of how animals are perfectly built for the specific world they live in.
Wow.
Another curious question kids ask about gills is if humans could ever grow them. To all my sci-fi fans out there, I'm sorry to say that the answer is no. Or at least nearly no. Over the course of 300 million years, our entire body is built to process and take in oxygen through air. However, when humans are still in the earliest stages of development, they do have something called pharyngeal arches. In fish, these become gills, but in humans, they eventually transform into parts of our ear, jaw, and throat. So, we don't have gills, but we do have leftovers of the same biological blueprint. The next time you see a fish gulping at the glass, you'll know it's actually performing a high-speed, high-efficiency experiment to stay alive. It's a tiny reminder of the incredible ways life has adapted in every corner of our planet. Thanks again to Zoe for such a great question. And remember, if you have a question you're curious about, submit it on our website, iwonderpodcast.com, and we might just feature it in our next episode of I Wonder. Until next time, stay curious and keep wondering.